Okay. So for example, this example, they're saying find the proportion under the standard normal curve corresponding to the following interval p z less than 2.73. So I have just opened the table over here. So let's study 2.73. Okay, so I have to find 2.73 on the table. So this is z. So I will go to the two value of two. This is negative values. I will go to the positive values. I will go to 2.7 over here. And from the 2 point line of 2.7, this is the line of 2.7. I have to go to 0.03. It's 1, 2, 3, fourth line of 0.03. This, so from 2.7, fourth number. Yes, this one. So it's going to be the 0.9968. So this will be our answer for the example. Let's go back. 0.9968. So in this way, we're going to use table in our calculations. Okay, let's see more. P is greater than Z is greater than 1.16. Answer, we cannot just take the proportion for the Z is equal to 1.16 entry in the table 2, because this gives us the proportion to the left of 1.16 and we want the proportion to the right. So because now in the last example, it was less than 2.73. So we exactly get the value. But in this, it is greater than 1.16. So in the case of greater than, what we have to do, we can use the symmetry of the normal distribution. The area of the to the right of Z is equal to 1.16 is equivalent to the area of left Z is equal to minus 1.16. So now Z is greater than 1.16 should be equal to Z is less than minus 1.16, which is equal to 0.1230. So the area to the right of Z is equal to 1.16. If this is 1.16, so area to the right of this should be equal to area to the left of the negative one. These two areas should be equal. So we cannot find this one, but we will go for this one. Area Z is less than minus 1.16. Z is less than minus 1.16. So let's find out. Minus 1.1. 1, 2, 3, 4, 5, 6, 7. So this is the value 0.1230. So it's minus 1.1, and from above I see 6, so it's 0.1230. So here it's 0.1230. So what we have to do is, when it's greater than, so it was P is Z is greater than 1.16. So we have to write it is equal to P Z is less than, and sign would be changed, minus 1.16. So if we will find this one, this is equal to this one, so this will be our answer. Okay. So next is, we can use the fact that the entire area under the curve is 1. Also, we can use the fact that we know that a density curve has entire area equal to 1. We know this one. From table 2, we see that probability of Z is less than 1.16 is 0.8770. Probability Z greater than 1.16 is 1 minus probability of Z less than 1.16. So we can also do this thing. If we have to find out probability P of Z greater than 1.16. So we don't know how to find Z greater than 1.16. So what we can do is, we can write, we know the total area is always 1. So 1 minus P of Z less than 1.16. Are you getting it? So this is greater than 1.16. So we will do total is 1, 1, and we have to find this part. So less than 1.16. So we know that 1 minus, we just calculated 1.16, that less than 1.16 is 0.8770. And when we will subtract it, we will get 0.1230. So this is also the case, we can do it in this case. Now we have to find P, Z is greater than minus 2.23 and less than 0.67. Sketching the areas of this type of questions is particularly helpful. First, we see that PZ is less than 0.67. So this example has two cases. First of all, we are going to work for this case only. Z is less than 0.67. So Z is less than 0.67. So let's see. Now 0.67. So now 0.6 and 7. So 0.67. This is 0.7486. So this is 0.7486. So first we worked on this part of the question. Now next, but this area is too large as it also includes the area below minus 2.3, which is area we want to cut it off. So we need to subtract PZ is less than minus 2.23. So now because we need to find the area that is Z is greater than minus 2.23. Now, if this is minus 2, minus 2.323 is this. For example, this is minus 2.23 and this is 0.67. So we have calculated the area of Z is less than 0.67. So it means we have calculated all of this area. But we actually don't need to calculate all of this area. We actually just need to calculate the area, which one? Just this part one, this part one. This includes this part too. So now we have to subtract this part. That is less than minus 2.23. Are you getting the point? So we are going to subtract this one part, the smaller part. We don't need this part. We need from minus 2.23 to 0.6. So we need this part. But when we calculate it in the first, we get all of the area. Now we need to subtract this part. So what is this part? That is less than minus 2.23. So we just need to work it out that we just do the first part and we calculate it that is less than 0.67, but it comes all of the area. Now there is some area over here that is less than minus 2.23, the area in which it is less than minus 2.23. I have to subtract that part to get the actual value. So minus 2.23. So it's going to be minus 2.2 and 3. So it's going to be 0.0129. So it's going to be 0.0129. So when we subtract these two things, P of this and less minus P of this, so we get 0.7357, which is actual area. So got it? First of all, we calculated all of this area. First of all, we calculated all of this area. Then we subtract this area. So we get this area that is a shaded part. So in such type of questions, when we have two things greater than and less than, when we have two things like this. So in such type of questions, inequalities, when you have two inequalities, first solve one inequality, then opposite the same. You have to make this inequality opposite because it is saying z greater than minus 2.23, but you will do z less than minus 2.23 and then subtract them and you will get the correct answer. Hope you understand what I am saying. So this is the correct answer. So we have now seen several examples finding proportions under the standard normal curve. In summary, for any values of B and C, B less than equal to C, P of Z less than B, table entry corresponding to Z is equal to B. P of Z greater than B, 1 minus table entry of B. P of Z greater than B less than C, table entry for C minus table entry for B. P of Z is equal to B is equal to 0. Our goal is always to rephrase the problem so that it only involves areas to the left we can use the table. Now, what are they saying? These 4 points are very important. If they will say P of Z less than 0.67, what you're going to do, you are going to go to the table and check where 0.67 is lying, where is Z is equal to 0.67, and you will get the answer. If they will say P of Z is greater than 0.67, then what you have to do, you have to subtract minus 1 minus the value of Z is equal to 0.67. This will give you the answer. If they will say P of B less than Z less than C, it means there are two things like this. So what you will do, you will enter P, this value of Z on C, minus value of z on b. If they will say z is equal to b, if they will use a sign of equal to, simple, the answer is 0. You don't need to go to the table. The answer is 0 in case it is equal to 0, equal to b. Now that we know how to find any area, we can find the actual proportions we approximated with the 68, 95, 99.7 rule. So z minus 1 to 1. So now how to find the proportion for, remember, we just read the rule. See, the third rule. P of B less than Z less than C is equal to table entry value for C minus table entry value for B. So here the rule is applied. Z minus 1 to 1. It means P of Z less than 1, this part, minus P of Z less than minus 1. So we are going to now solve this. So now P, stable value of Z on 1. On 1, it's 0.8413. 0.8413. So I will write 0.8413 minus, now table value of Z on minus 1. This is minus 1. This is minus 1. So it's 0.15, 0.1587. And when you will subtract it, you will get the answer. So this is how we get the answer for Z minus 1 to 1. Now for Z minus 2 to 2 and minus 3 to 3, how you're going to solve it? I'm giving you 2 minutes. Solve with the help of table. This will give you a practice. Solve with the help of table minus 2 to 2 and minus 3 to 3 using this rule. Got it? You will do 2 steps. Solve it on your notebook.
Unable to solve.
Unable to solve?
Mm-hmm.
Okay, let me guide you. Basically, what is happening is P of -2 less than Z less than 2. Got it?
Yeah.
What you're going to write? You have to write P of Z, which is less than this number first. First of all, we're going to use, I'm going to change the color. Firstly, we're going to use this number, 2. So Z is less than 2. Got it? Minus P of Z is this number, less than -2. So are you okay with this statement? P of Z is less than
Yeah.
2, first the right side and then the left side. Got it? Now
Yeah.
I'm going to go to the table to find the values of this, then this. Okay, let's see. This is the table. Okay, I will do it in front of you. I have to find the value of P of Z less than 2. So I will find 2 in my table on the right side. This is the Z. This is called Z. So you can see this is written over here Z. So in this column, you're going to find 2 because this is 2 now. This is written 2. So you have to find
Mm-hmm.
2 in this column. Let's find 2 in this column. This is all negative values. I can't find 2 over here. I will go down. These are all decimal values. Here I find 2. So 2.0 is same as 2, right? This is 2.
Yeah.
Can you find
Yeah.
2 now? Now
Mm-hmm.
in this column, what is this written? 0.00, 0.01, 0.02, 0.03. But we have only 2. We don't have 2.03, 2.02, anything. So we will go for 0.00. If it is only 2, it means it's 2.00. It's obviously it's 2.00. So this is the case. So did you get it? If it's only
Yeah.
2, it means it's 2.00. So let's find 2 again. So this is, I find 2, and from here I have to find 0.00. This is my answer, 0.977. So my answer is 0.9772, correct? Minus.
Yeah.
I have to go on P of Z less than -2. So I will find -2 on my Z1 column. Let's find -2. Is this -2?
Mm-hmm.
And it's -2.00. So if it's -2, it's equal to -2.00. It's one and the same thing. So I will go for this one. This is the first one. First column is always 0, 0. It's written over here. In the top, it's written Z. It's written 0.00. So it's the same thing. So I am going on. Where is my -2 gone? This is -2 and this is the one. So I got 0.0228. Now subtract both of them.
0.949544.
So you get 0.9544. You get the correct answer. Okay.
Okay.
Now try yourself for P -3Z -3. I will write it over here. P -3Z3. This one. Try this one.
Zero 0.9974.
Yes, so now you got it correct. Now I'm giving you some practice questions. I'm going to give you a few questions and you have to find the value looking at the table of Z. So this will help you practice. Okay. P of Z less than 1.37. Now you're going to follow those 4 rules that we learned. I will make you revise them too. P of Z less than equal to minus 0.62. P of Z greater than minus 0.89. P of Z greater than equal to 2.03. I'm giving you just a simple one first. P of Z is greater than 4.17. So I am not giving you the two inequalities one. I'm giving you one inequality. So you have to follow these rules. I'm going to tell you these rules. Keep these rules, write down these 4 rules somewhere on your notebook because you have to follow them. When it is less than, you have to go to the value exactly. But when it is greater than, you have to do 1 minus and then that value. Okay, so first of all, in these given questions, you have to follow only 2 rules. But then I will give you the rule, some questions for the third rule too. Are you getting my point?
Yeah.
Okay. Can I come to the table? Okay. Even you can look the table at your phone or something, and then you can follow this. So we are done with the normal distribution. So in the case of normal distribution, we have 4 points. One is Z is less than B, Z is greater than B, Z is between B and C, and Z is equal to B. And whenever there is a sign of equality, it is equal to 0. And for other things, we have 4 cases. So we have learned it. How did we find out for P of Z minus 1 to 1, minus 2 to 2, and minus 3 to 3, looking at the Z table. Now, suppose we want to go backwards, that is, find the value of Z such that the proportion Z less than Z is equal to some specified value. For example, find the value of Z such that P Z less than Z is 0.2843. Rather than looking in table 2 at a specific value of Z, we search the body of the table for the proportion 0.2843 and determine to which value of Z this proportion corresponds. We see from table 2 that PZ minus 0.57 is equal to 0.2843. So Z is equal to minus 0.57. So we have to find 0.2843. 0.2843. Now this is the reverse one. So 0.2843, where you're going to find it. 0.27. 2623. Can you see somewhere 0.28? This is 0.2843. So what is the value of Z over here? The value of Z over here is minus 0.5 from this side, and from upper side, this is 0.07. So it's minus 0.57. Do you get this? Minus 0.5 and 0.07. So it would be minus 0.57. So this is the reverse case that we have done. We first find the value of the value of 0.2843 inside the table and find the value of Z. Find the value of Z such that P of Z is greater than Z is equal to 0.1251. We can't just search for the value of 0.1251 in the table 2 because this value will give us the value of Z with area 0.1251 to the left. We want to know the value 0.1251 to the right. So we will search for the value of Z. So whenever there is a sign of greater than, we have to go for the minus. So we have already learned this, that whenever there is a sign of greater than, we will go for the minus one. So it's 0.1251. P of Z is equal to 0.1251. We cannot find this. We will go for 1 minus 0.1251. What is the value of 1 minus 0.1251? It's 0.8749. Now we are going to search for 0.8749. Now we will search from the table 0.8749 and let's see what we'll get. 0.8749. Okay, search it. Can you search it? 0.8.
It's up.
No, it's not up. It's 0.87. This is 0.8749. This is the value. So it's 1.1 and 0.05. So 1.15. This is the value. Got it? So whenever
Yeah.
you will get P of Z less than Z, you will just directly find the value. But if it is Z greater than Z, then you have to do 1 minus this and then find the value. So this is the rule that you have to follow. Okay. Find the interquartile range of the standard normal distribution. The first quartile is the value of Z such that P of Z is less than Z. We see table 2 that the value of Z is closest to minus 0.67. So Q1 is minus 0.67. Similarly, by symmetry, the value of Z with the area 0.7500 is to the left and its Q3 is 0.67. The interquartile range is therefore Q3. So we know interquartile range is Q3 minus Q1. So we will find for 0.67 for positive one and then for negative one, and then we will subtract it and we will get the answer. We can find the proportions for any normal distribution by first standardizing our normal variable x. For example, suppose it is known that pulse rates of healthy adult females follow a normal distribution with mean 74 beats per minute and standard deviation 12 beats per minute. Okay, so what proportion of healthy adult females have pulse rates above 57 beats per minute? So x is greater than 57. So now we have to find it. Okay. So what are they saying? They're saying that we have mean 74 beats per minute. So mu is equal to 74 and standard deviation sigma is equal to 12. So we are given two values. We have to find Z. We know the formula. So this is very easy. We will just go for Z is equal to x minus mu over sigma, right? What is x? 57 minus 74 over 12. So I will get the value minus 1.42. Now, what is this happening? Minus 1.42 is the value for this. Basically, this is P of x is greater than 57. So we solve this equation. X is greater than 57. We are solving this one. So it is P is Z is greater than 57. We're converting this X to Z. 57 minus 74 by 12. So we get P of Z is greater than minus 1.42. Now we get our question in the form of Z. The question was actually in the form of X, but by using this formula, we convert the question in the form of Z. Now this is greater than sign. So whenever we have greater than sign, what should do? Convert it to the 1 minus thing. So we will do 1 minus P of Z less than minus 1.42. Are you getting my point? So 1 minus, what is the value of this in the table? 0.0778. So when we will subtract it, we will get 0.922. Got it? Basically, the question is given in the form of x, but by using this formula, we will convert it in the form of z. And after we get in the form of z, we will use the same all techniques that it is greater than, we will do 1 minus and less than and then solve it. Okay. In a sample of 500 healthy beauty adults, about how many would we expect to have a pulse rate over 57 beats per minute? We would expect about 92.22% or 0.9222. Of them have a pulse rate of 57. We have just calculated this. 0.922 is just the thing that we calculated it. What proportion of healthy adult females have pulse rate between 75 and 87 beats? Now this is a question which is different. So we have to calculate for between 75 and 87. So what we're going to do is P of 75 less than x less than 87. So we are going to solve two of them. So P of 75 minus 74 by 12. Now what is 74? This was mu. And what is 12? This is sigma, which is given. Less than, now x is converted into z because we are using the formula to convert x to z, which is less than 87 minus 74 by 12. 74 and 12 are given in the question. This is mu and this is sigma. Are you getting it? So you will get P 0.08 less than Z less than 1.08. So it means you will get P. Now how to solve this one? We have just practiced to solve this one. First we will write the last one. P Z of 1.08 Then we will subtract, then we will write the first one. P, Z is less than 0.08. Then simple table rules will give us the answer 0.3280. Got it?
Mm-hmm.
Okay. The lowest 10% of pulse rates are below what value? Rather than being given a value of x and asked to find the proportion, we are now given the proportion and asked to find the value of x. So we want to find the value of x such that p of x less than x is equal to 0.10, the 10th percentile of the distribution. So what we will do? We will do the two steps. Find the value of z such that p of z less than z is 0.10. From the table 2, we will find the value of z of 0.10 and we will find that it is minus 1.28. Now, we will transform z into x. So first what we will doing, we were transforming x into z. Now we have to do is we will transform z into x. So z is equal to x minus mu over sigma. So z into sigma is equal to x minus mu. So z into sigma plus mu is equal to x. So we know the value of z is minus 1.28. We know the sigma is 12 and mu is 74. So we will get the value of x. We are doing the reverse thing now. We have thus determined that P of x less than 58.64 is equal to 0.10 and 10% of pulse rate is below than 58.64. So percentage grades in large economic class fellow a normal distribution with mean 65 and standard deviation 10. Now this is another question in which the mean is 65, mu is 65 and standard deviation is 10. Then another mu is psychology class fellow with normal distribution mean of 72 and standard deviation of 8. So one student got 80% in economics and 82% in psychology. So now this is another question in which there are two Zs. One is ZE and one is ZP. So how to find Z? XE minus mu E over sigma. We will use the same formula in different values and find 2Z. Normal distribution. Although the student got a higher percentage grade in psychology, her score in economics was actually better relative to the test in the class. She did better than 93.32% of students in economics and 89.44% of students in psychology. We have seen how to find proportions corresponding to some area under the normal curve, as well as how to determine the value of x corresponding to the given proportion. There are two other quantities in the z-score formula that we may be asked to find mean and standard deviation. The lifetime of a certain type of battery follow a normal distribution with mean 367 hours. It is known that 33% of all batteries of this type last longer than 400 hours. What is the standard deviation of the distribution of battery lifetime? So mu is given 367. P of x is greater than 400, which is calculated from the table 0.33. X is 400, so we will find the value of z, use the same formula and get 75. So these are the figures. Now another example. Labels on shampoo bottles claim the bottles contain 425 ml of shampoo. In fact, the bottles are filled by a machine and fill volumes are known to be normally distributed standard deviation of 3 milliliter. The machine has dial to set the mean fill volume. To what value should the dial be set so that the 5% of bottles contain less than the amount on the label? We know sigma is equal to 3, x is less than 425, same values are coming. We will just put the values in the value of z and we will get the answer. So these are the two formulas used. If we have to find, if we are given with x, we can go to the z. If we are given with x, we can go, if we are given with z, we can go to the x. Similarly, we can find sigma, we can find mu. So these are the four formulas that are extremely important. This formula helps us to find z. This is for x, this is for sigma, and this is for mu. And you know all of the formulas are same. Z is equal to x minus mu over sigma. If you want to find x, what you will do? Z into sigma plus mu of is equal to x. This is for x. If you want to find sigma, what you will do? Sigma will go there. Sigma is equal to x minus mu over z. This is for sigma. You can see? Now, if you want to find mu, what you will do? Sigma into z minus is equal to x minus mu. So you have to find mu. So you will do mu is equal to x minus z sigma. Z sigma will come here, mu will come here. This is just you are doing the algebraic rules to get all the formulas. Are you getting it?
Yeah.
So this is all about normal distribution. If you're done with it.